You pay a $1,500 markup purely for a plastic case and logo. Big tech companies want you to believe packed lithium energy is dangerous magic. Only their certified factory engineers can safely handle. Right now, $500 of raw components delivers the exact same surge as a $2,000 luxury power station. The core internal hardware inside both units is practically identical. One wrong wiring connection can trigger a thermal runaway that melts your garage to the ground in seconds. Yet off-grid survivalists are actively ditching brand-name power boxes for modular rigs assembled on a workbench. The ultimate difference is not raw capability. It comes down to whether corporate safety is a genuine necessity or a $1,500 illusion. To understand why someone would build their own power station, you first have to look at the commercial gold standard. The Bluetti AC200L weighs 62.4 pounds. Inside the unit sits a high-capacity lithium iron phosphate battery storing 2,048 watt-hours of reliable, continuous electrical energy. It delivers 2,400 watts of continuous alternating current power, which is easily enough to run a full-sized refrigerator and microwave simultaneously. The unit easily handles surge loads up to 4,800 watts without tripping breakers. It recharges from solar panels at up to 1,200 watts, topping off in roughly 2.5 hours under ideal sunlight. If grid power fails, the system switches to backup power in under 20 milliseconds. You do not just pay for raw energy storage, because you are also paying for engineering and official safety compliance. The unit holds certification under UL 2743, a rigorous standard for portable power packs. An internal battery management system constantly monitors cell temperature, voltage, and current to prevent dangerous thermal runaway during operation. It comes backed by a factory 5-year warranty. Encased in a flame-retardant housing, the system represents convenience, safety, and turnkey reliability. This complete plug-and-play fortress carries a steep price tag. Retail costs often top $1,200, and historically this unit has reached price tags of up to $2,000 to construct a functional solar generator for under $500. Every single component must be stripped down to its absolute minimum. If you search through discount listings, the cheap numbers quickly begin to appear. A budget 12-volt, 100 amp-hour lithium iron phosphate battery can easily be bought for $166. Adding a basic 500-watt pure sine wave inverter costs another $50, which keeps the total cost remarkably low. Pairing that unit with a 20-amp charge controller adds another $55 to the running balance. Including used solar panels, cables, fuses, and a modest box brings the final bill to $496. On paper, the build is complete. Under real-world testing, that financial illusion completely collapses. The budget battery provides just 1,280 watt-hours of nominal energy right out of the box. After accounting for inverter efficiency losses and depth of discharge limits, actual usable energy drops to roughly 1,037 watt-hours. That represents just half the total storage of the factory reference unit. The output disparity is even more severe when compared directly. While the factory unit provides 2,400 watts of continuous alternating current output, the budget build caps out at 500 watts. Attempting to run a standard 1,000-watt microwave on this setup fails instantly. In fact, the budget inverter trips before the magnetron even turns on. To achieve that $500 target, the system sacrifices over 50% of its capacity and nearly 80% of continuous power. Physical reality strikes hard when pushing budget 12-volt systems to commercial power levels. Drawing 2,000 watts from a 12-volt battery requires roughly 167 amperes of continuous current through your system. By comparison, a commercial 51.2-volt architecture draws just 42 amperes for that exact same load. Lower voltage demands exponentially higher current, requiring thick copper cables and absolute precision at every single connection point. A loose terminal lug creates severe electrical resistance. That buildup of resistance converts excess amperage directly into scorching heat inside your battery enclosure. Many amateur builders assume an internal battery management system will prevent every potential fire. While a basic circuit board monitors cell voltage and internal overcurrent limits, it remains completely blind to external issues. That means it cannot detect rising external cable heat, improper fuse placement, or inadequate overall enclosure ventilation. Fire protection standards explicitly warn that lithium battery failure triggers violent thermal runaway. This dangerous process produces extreme temperatures, toxic flammable gases, and aggressive fires that can easily reignite hours after initial suppression. To address these risks, standard NFPA 855 outlines strict mandates for containment, gas venting, and active fire detection. Commercial power stations earn UL 2743 certification through rigorous whole system safety tests. Wiring individual certified parts together inside a plastic toolbox does not create a certified or safe finished product. Ultimately, a single miscalculated fuse or undersized wire quickly converts a budget build into an uncertified thermal hazard. When an all-in-one system fails past warranty, you face a dead end. According to Bluetti, the internal battery inside the AC200L is not user replaceable. Furthermore, third-party expansion batteries are blocked. If the integrated inverter board burns out, the entire $1,200 unit becomes completely useless. This represents the real financial risk of integrated consumer hardware. Modular systems operate under a completely different economic life cycle, because every single component functions as an independent node. If a standalone pure sine wave inverter fails, you only replace that specific part for roughly $50 to $100. Meanwhile, the main battery, solar charge controller, bus bars, and safety fuses all remain untouched and fully operational. That is the true modular advantage. System upgradability follows this exact same principle. Commercial units restrict future expansion to proprietary battery packs that carry massive manufacturer markups. A custom modular system allows you to connect off-the-shelf lithium iron phosphate batteries from virtually any manufacturer. You can start with a single 100 ampere-hour battery and gradually expand storage capacity whenever your budget permits. You're never locked into a single brand ecosystem or reliant on a company continuing to support legacy equipment. Building modular admittedly requires accepting higher initial complexity along with separate component costs. However, it trades temporary setup convenience for absolute long-term ownership over your equipment. While a sealed box leaves you dependent on factory warranties, modular systems give you complete control over every single watt. A $500 build cannot match 2,048 watt-hours of capacity and 2,400 watts of output. Achieving those specs requires high-voltage architecture, which pushes total component costs far beyond $500. Basic entry-level kits fail on continuous output and safety certification. Commercial units offer system listings Underwriters Laboratories 2743, a 5-year warranty, and 20 millisecond switching. You pay $899 to $1,200 for factory integration, compact portability, and zero assembly liability. However, when an internal component fails outside warranty, the entire commercial box becomes electronic waste. Modular systems win on repairability. Failed charge controllers or worn battery cells can be replaced in minutes using standard off-the-shelf parts. The decision rests on technical willingness versus factory convenience. If you need portable power for job sites or plug-and-play backup, buying an integrated station is logical. If you want a fixed off-grid installation where parts can be serviced and expanded, you build. Financial savings are real, provided you engineer for safety before tightening the first battery terminal.